So that's PD. And so what we're doing is we can call it an abbreviated version. We could call it shorthand. That's kind of abbreviated, isn't it? Or we also could call it the noble gas configuration. All right? Because we're going to use a noble gas for this. So I want to do the orbital notation for palladium. So, I'm sorry, electron configuration first. So 1s, 2. Let's see, so 1s includes hydrogen and helium here in the s sublevel region, first row, 1s. Then lithium and beryllium, that's the second row. All right, so that's 2s. And there are 2 electrons there, so that's 2s2. Got to have this whole section over here. This is the p sublevel region. We're still in the second row. So it's still 2, but now we're in p. And there's 6 electrons represented by these 6 elements over here. So it's 2p6. Then 3s2. Then 3p6. Then we get down into 4s. And there's 2 elements there, so 2 electrons. Then here we get into the D sublevel region, and we drop back 1 primary level, so we're filling up 3D instead of 4D. And there's 10 elements in here, so we need 10 electrons. We're trying to get down to palladium, the next row. Okay, palladium's down here. All right, so then we're going to go over here and start back in the 4th. We're still in the 4th row, so this is the 4th primary level and p sublevel. So this is 4p. And there's 6 elements over here. 1, 2, 3, 4, 5, 6. That's 4p6. Go to the next row, starting with rubidium. We got 5s. What? Well, there's 3d10. Is that what you mean? No, you need 4p6.
What does it count?
Huh? This is the D sublevel region starting right here. 1, 2, 3, 4, 5, 6.
So it counts
just the D? Just the piece, the D sublevel, this is this region right here. Okay? And there are 10 elements in here. So that's when we can have 10 electrons in the D sublevel region. Okay? So Ds can have 10. Did we not get to that yesterday?
That whole row though, how much is in that whole row with all of them straight across?
All the way across?
Yeah.
18.
18 all the way across?
Yeah.
Okay.
So if we count 2 and 10 and 6, that's 18.
Okay.
But remember, we're dropping back 1 level to put in these right here, right? So technically, even though we've got 18 elements here, we're only putting 8 electrons in the outer energy level. So in the 4th energy level, there's only 2 and 6 is 8. Of course, 3 drops back a level. Okay? All right, so now we're at 5s. This is the right row we want to be on. 5s2, yes, I heard somebody say that. And then we just count 1, 2, 3, 4, 5, 6, 7, 8, and that's palladium. So that's 4d8. Let's check that. 4d8. Okay? And that's the electron configuration that you've been taught so far. All right, that's big. That's long. That's a monster, huh? Okay. But you need to know how to do that. But I want to show you a way to write it shorter. Now, you need to be able to do both, okay? And really, after this unit, you can use the shorter version if you want to, okay? But right now, we're just going to do we're just going to learn how to do that. Now, what I want to do is to show you that palladium, up to, let's see, this point right here, okay, palladium has the same electron configuration as Krypton. Okay? I'm going to show you that. Here's Krypton. I did tell you there's no such thing as kryptonite, right? Okay. So if we were writing just the orbital or electron configuration rather of Krypton, it would look like that. And can you see that all this stuff in there looks the same? That part's the same? Does that make sense? Up to this point, I'm sorry, actually I should include 4P6. I don't know why I stopped there. Up to that point right there, everything is the same. Right? Now, without going into too much complexity here, when we get into bonding of elements, the only part that's going to matter to us is this part up here. Okay, what are you confused about?
Like, when you go, and he was like, I think it was for the middle part, and he was like, I guess you drop back to the 4.
I drop back to the third level. I'm starting in 4, and 3D has to drop back one primary level. So instead of 4, it goes into 3, and then back up to 4 when we get to P. Alright, so we're starting here. That's always for the D sublevels. Always for D sublevels, they drop back 1.
So it's always going to be like, if it's right here, it's going to be like 3D.
If you mean here, you mean this section here? This is 3D. So we're starting in 4. This is 4S, then 3D. 5S, 4D. That makes sense? Yep. D sublevels drop back 1. It actually gets more complex than that, but I'm not. I need to look and see if what we decided over the summer about including some of the more complex stuff later. We'll get to that. Okay. The state standards say we're supposed to tell you you're supposed to know about some exceptions, but I need to look and see what the department decided. All right. I've always talked to the standards. We'll have to see how that works out. Okay. Can you see that the electron configuration for Palladium up to this point is the same as the electron configuration for Krypton? Okay. And because the only part of the electron configuration that really matters to chemists is the part that is involved in bonding, and that's this part up here. We don't really need this part in here so much. We really just need this upper part here. So, we've come up with a kind of shorthand or abbreviated or noble gas configuration. Okay? And what we're going to do is we're going to replace all of this right here with the next lowest noble gas symbol. Okay? So what we're saying is, up to this point right here, it's all covered by Krypton. Does that make sense?
Yeah.
And so all we got to do is just write this much, then 5s2 and 4d8, and that's a reasonable electron configuration for Palladium. Hmm? Just the 5s2 and 4d8 is all we need in this. They are for Krypton. Huh? Anyone you want to. You go back to the next lowest noble gas and just start from the end of it. Start.
So basically you saying we can put what's the one under helium?
Neon.
So you're trying to say we can put like.
Let's say I'm doing the electron configuration for aluminum. Okay? So here's aluminum. And instead of writing all the configuration up to neon, I'm just going to put neon in there. And I'm going to start after that. So this over here, we're starting at 1, 2, 3, 3s, 3s2, and 3p1. That gets us to aluminum. Are you with me?
Does it always have to be the last number in the row there? The last thing?
Yeah, you always have to take out just the noble gas stuff. You can't take out anything else.